And then the B part is actually to find it in IPY, right? And because of this inch here, we know it's actually corrosion penetration rate, right? So B is looking for corrosion penetration rate, right? So that's basically corrosion rate and divided by density. But then it's very important that we, because we are following this method, you know the unit. The this here, this corrosion penetration rate, they want it in inch per year, right? And then this one, the corrosion rate that we have here is in milligrams per decimeter square per day, right? So that would mean that anything that involves, so here, this is length, this is here. Anything that involves length has to be changed to inch. Everything that involves what's it mean? Year, time has to be changed to year, right? So that's how it's done. For in order for you to do this, right? So that would mean that even if we are using density here again, we have to change it to match what we are doing, right? So let's see. We are going to do it step by step. So let's start with the density, right? So we have the density for the iron, right? So let's see. I do this step by step. So density is what's the name? 7.86 grams per centimeters cube, right? So that will mean that we will have to change. So you see, here's length, inches in length. This is here. So if it has any of these one, then we have to change it to match. We have to change it to match this, right? We have to change. So this is our target IPY. I have to change it to match this IPY. So length and then year. This has some length involved, right? So we can change it to what's the name? Inch, right? So that's what we have to do. So that will be 7.86 grams, right? And then we are changing this to inch, centimeters cube to inch. So let's see conversion. Okay, so centimeters to inch. So let's see this. So if I have one, let's do it the other way around. We're actually changing this. So here we are changing centimeters, centimeters cube to inch, not just inch or inch cube, right? So, but there's a way to go about it. It's not that complex. So first, you have the calculator by you can do the conversion. So let's see conversion. So we are changing centimeters cube to inch, right? So let's see. So if you have 1 centimeters, it gives us this. So 1 centimeter, 1 centimeter is equal to 50 on 1 is 50. 50 on 127 inch, right? So if we are looking for centimeters cube, that will mean that we just have to cube this, right? And then the result that we'll be looking for will be this cube in inch. That is it, straightforward, right? So that will mean that here, if I change the centimeters cube to inch, it will basically be to inch cubed. That will be 50 on 127 cubed in inches, right? So this here will be just inches cubed. That is it, right? So that is it for the density, right? So we end up getting 7.886 on this cubed square. When it comes to this one, it's safer for me when I'm doing it. I think it's safe to just put everything in brackets and then put a exponent there so that you don't get confused and putting it on one. So 50, 127, right? So this is the answer we are getting for it. So we end up with a density of 128.80. So 128.8023 grams per inch cubed. That is our density. That will be using in order for us to get the answer straightforward. That's within the A part, right? And the correction rate that we are having, so the correction rate, we have it in mmd, right? So that's 422.6028 m, that's milligrams per decimeter square per day, right? So that will mean that all that we have to change will be anything that has length, and then here time has to be changed, right? So we have so the milligrams is the same, we maintain it. And one more thing, you see here we have to, yeah, whatever that we are doing here, because the mmd we actually use milligram to find that one. That would mean that when we are doing the computation we have to make sure that the density as well is in terms of milligram, right? So that would mean that there has to be a slight change here. If you know the procedure you have to use, it won't be that messy. It may look messy, but it's not that messy, right? So let's minimize this. Okay, good. So that will mean that if we are changing, this is in grams, if we are changing it to milligram, that will be times 10 to the power 3, and that this just be in milligram, right? So that will ensure that this one here will be in milligram. So let's see what we have. So this is times 10 to the power 3, right? So this is what we get. So we end up with 128,802.32304, this 40 dB, right? Milligram, let me write this out. Milligram per inch cube, right? Milligram per inch cube. So that's what we have. And then for the corrosion rate, we have it in mmb, right? So that would mean that we'll have to, our interest is to be in IPY, right? So anything that has length in here and time has to be changed. So there's length, so that would mean that this is decimeter, we'll have to change it to inch, right? This is day, which is time, we'll have to change it to year, right? So let's see. So the corrosion rate to be the same as 422.6028, right? And I remember, it's very important. At times it might look this way, but the actual thing is not m. It might even be, you might even see it as m per d, but the arrangement is not that way, right? The general arrangement is basically we have, what's it mean? We have this is mass, right? And then we have area, which is decimeter squared, and then we have d. So this is the actual thing, how the things actually arranged. It helps you to actually do the conversion easier if you understand that it is this way, right? Okay, so let's put that somewhere as well. So we have m, and then we have d squared, and then we have d, decimeter squared, and we have d, right? So yeah, and then we are trying to change all those to, what's the name, inches and year. This one to inches, this one to year, right? So let's see. If we are changing the decimeter squared to year, so if the calculator doesn't help you do that, that means you have to change it to centimeter, and then you change centimeter square, and then change it to inches, right? So let's see. So decimeter squared, so decimeter squared, decimeter is 10 to the power minus 2, right? Meter squared. So that will be the same as if we want to change to centimeter, that will be 10 to the power 2 centimeters squared. So that will be 10 to the power 2 centimeters squared. And the reason being that this decimeter here, this centimeter squared, if you bring it out, it ends up being 10 to the power minus 4. So 4, it takes care of this 2, and then you'll be left with an extra minus 2, which will be the same as this, right? The main thing is just to find a way to get it. But if you understand this one too, it's fine. You can use it this way, right? So let's see. So this is 10 to the power 2 centimeters squared, right? So then the only thing I have to do now is just change to inches squared, right? And then if I'm changing to inches squared, I know that 1 cm is equal to that 50 on a 127 inch, right? So then if I want to square it, that will mean that if I'm having 100, the 100 squared, to basically be that this is, so that's this one, right? If I'm changing that to, inches, right? So that would just, so 100 to 10 squared cm squared will be the same as 50 on 127 squared, so that's h squared, and then I'll just have to divide through by the 10, the 10 squared, right? So by 10 squared, and that'll give us the centimeter in inches directly, right? Yeah, it's actually long though, but if you understand it this way, you can follow through, right? So this one here will just give us everything, or the length in inches squared. So this one will end up being in inches squared, right? So let's see. If I put that here, that help me to convert that, right? And I know this is the decimeter is at the bottom. I'm changing it to inch, it should be at the bottom, right? So that will just clearly mean that I have all this on what I'm having here. So that's the 50 on 127 squared, and I divide it by what? The 10 squared, which is 100. So this one here is 110, right? So I've successfully changed the decimeter squared to inches squared. The only thing I need to change now is day, right? I have to change the day to, this one here is in year, right? The IPY is in year. So how do I go about that? So that will mean that, so the same thing here. If I have so basically it's day and I'm changing together, I'll just have to divide it by 365, right? So, and then again, I know the day is at the bottom, right? So that will mean that I have to do, this is times, right? Which is this here, right? So that will mean that I have to do 1 on 365, right? Because this one here, we change directly. This one here, we are just dividing, right? This one is just straightforward, 365. So let's see what we get for that. So has everything been converted? So there's a CR as well. So that will mean that our CR is now being changed, right? So our corrosion rate, so corrosion rate here is being changed from MDD, that's so milligrams per decimeter squared per day, to milligrams, right? It was just M, right? So let me do milligrams per inch squared. This is an arbitrary unit. It's not used a lot, but then this is just for us to see clearly what we are doing, right? Per inch squared per year, right? So to make it easy for it to match the IPY, right? For us to be able to go straight to IPY, so that's why we are doing it. So the unit that we have now should be in this form now. So let's check the calculation that we have. So that's 422.6028, and then we have here this 110. So we have 50 on 127, and that's squared, right? And now we are dividing through that by 10 squared, right? And then we multiply by 1 on 365, right? 1 on 365. So this is what we are getting for the corrosion rate, right? Converting it to milligrams per inch squared per year, right? So this gives us 9. This is basically the CR, right? Corrosion rate. So we have 9,951,5,944 40p 0.1935, and the unit is this MIY that we've written, right? It makes it easy for us to just divide by the density for us to get the IPY, right? So we have let's write different. So that's MIY, right? So for us to get the corrosion penetration rate, we just use this CR, which is in M, let's see, which is in MIY, right? And divide through by the density, which we have in milligrams, right, per inch squared. So clearly you see that the milligram takes care of milligram. So milligram takes care of this milligram here. And then this inch squared, one of it is cancelled, just be left with inch, right? So we just be left with inch, right? And then we will have here, we have inch here. So that will end up giving us something close to the IP here. Right, so this is down. Let me make this clear. So basically we end up with the unit as this. The unit is very important. So we end up with the unit as here's y, here at the top, and then we have at the bottom we have and at the denominator side we have was 1 on inch, right? Which basically turns out to be right. So we end up with here. Let's see. Yeah, inch at the bottom. Yeah. So we end up with something like here, and then we have kind of like inch, right? Yeah. So which is similar to the IPY that we are looking for, inch per year, right? Yeah. So this inch at the bottom is level 1. We bring it up just inch. Yeah. So which is closer to the IPY that we are looking for. Right. So now the only thing for us to do is the computation. We have all the values that we need, right? So the CPI we are looking for will be this 199 something divided by the density that we had after all the conversions, right? The density was where is it? Oh, this, right? So let's see. So okay, let's make everything clear. The CPI that we have is the CR is this, which is the 99515944.1 sorry 1935, right? And the density that we had after the conversion, we have it to be, is it 1 2. I'm just there's a way to actually put everything in or save and put it there, but I just want to point it for us to see clearly what we are using. 128.3230304. Oh yeah, there's a slight overlook. You see when we go here, we said this is in decimeter, right? And we are changing it to inches, decimeter squared changed to inch squared. And then decimeter squared, right? Decimeter squared is basically this centimeter squared, right? 10 to the power 2 centimeter squared. And then if we are changing that to inch, inches squared, let's see. We are already aware that this is equal to this squared, right? And then 1 centimeter squared is basically 5127 squared inch squared, right? So that would mean that if we want this one will basically be more, right? Will be more. So this one here will just be this 5 on 1 to 50 on 127 squared times the 100 100, which is 10 to the power 2, right? So that will give us the inch squared that we're looking for. So this here should be actually be times and not plus. The conventions are a lot, but if you understand it, you can always go back and check out what you are doing. So that will end up giving us this. So that's instead of it being, so that means the exponent, the number of decimal places will so to change. So to go to by 2, right? So that's if I let's point this over again, right? So we have 422.6028, and then we have this times 101. This is 5. This is 5. Basically, this can go up, right? And it becomes 365, right? Clearly. and here's 50 on 127 squared times 10 to the power 2. Right. Yeah, so that's 9951, and the rest are decimals, right? So let's see. 1, 2, 3, 4. So that means this goes out, and I end up getting this unit here, this side. Yeah, so that's what we are supposed to use. So let's see. The corrosion rate is just this. The corrosion penetration rate is the corrosion rate divided by the density, right? So this here, okay, will be the answer. The CPR divided by the density we found, and the density was, after we converted everything, we had, what is it? Okay, so this is it. We had, yeah, this. So we had 1288.32.304. Yeah. So that gives us the corrosion penetration rate in IPY. So we have 0.0773 I. So that's inches, right, per year. Yeah. So that's it. All right.